Hello, my name is Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 11, Lesson number 10 on the tangent function. So up to this point, we've seen the sine function, the cosine function. We've harped on them. We've seen how they can be extended to any angle, positive or negative, by using the unit circle. But one of the trig ratios from last year Common Core geometry has been missing, and that's been the tangent ratio. Now, for the record, the tangent function, which is very important, still is not nearly as important as sine and cosine. Sine and cosine get used much more in terms of modeling real-world phenomenon than tangent. So today's lesson, and one more of them, we're going to be looking at the tangent function, but mostly just to make sure that you see how it can be extended using the unit circle to all angles. All right, so let's jump right into it. Now, what we know from Common Core geometry is that the tangent function, like the sine and the cosine function, can be defined using a right triangle. And in fact, what we saw back in geometry was that the tangent ratio was always equal to the side length opposite in the triangle divided by the side length adjacent to the angle that we're referencing. All right? Now, we can easily then take a right triangle, even with a missing side, and we can figure out the values of sine, cosine, and tangent. So for instance, in exercise 1, letter A, we've got this triangle that's missing one side, this side, right? But of course, we can use the Pythagorean theorem to find that side. Most of you, of course, are probably looking at this saying, I know that thing's got a length of 3, but if you didn't, you could say, oh, I've got 4 squared plus b squared is equal to 5 squared. And 16 plus b squared is equal to 25. B squared would be 9, and b would be equal to 3, right? But once I have that, then I can figure out the value of all those ratios. The sine of theta will be opposite over hypotenuse, so that would be 3/5. If you like decimals, that would be 0.6. The cosine of theta would be adjacent divided by hypotenuse. That would be 4/5, or 0.8. And the tangent of theta will be opposite divided by adjacent, and that would be 3/4. And again, that's referencing this angle, which is the one that we want to look at, especially because that's the angle that's going to show up in the unit circle. All right? Why don't you do letter B? It's a bit uglier, but I know you can pull it off. Okay, well, just like before, we need to find the missing side. So I'll have 1 squared plus b squared is equal to 2 squared. That's 1 plus b squared is equal to 4. B squared is equal to 3, and b is not so nice anymore. It's the square root of 3. Therefore, let's see, what did we start with? Oh, let me write down square root of 3 so I have it. The sine of theta will be opposite divided by hypotenuse. That should look a little familiar. The cosine of theta should be adjacent divided by hypotenuse. Again, familiar. And the tangent of theta will be opposite divided by adjacent, which in this case is just going to be root 3. All right, so easy enough. By the way, if you recognize that root 3 over 2 and that 1/2, that's because that's actually a 30-60 right triangle. All right, but we'll get into that more later. Pause the video now and write down anything you need to. Okay, clearing out the text. Now, so far what we haven't done is we haven't extended tangent past that just right triangle idea. So let's do that now with our friend the unit circle. So I've got the unit circle diagram there. Letter A says, if x comma y represents a point on the circle, how can we define the tangent function in terms of this point? This is kind of cool, right? I mean, we know that the tangent of the angle is the side opposite divided by the side adjacent. But the side opposite is the y-coordinate, and the side adjacent is the x-coordinate. So tan theta is simply y divided by x. Now, letter B says, given how we define sine and cosine, how can we define the tangent function, in terms of sine and cosine? Well, this is cool. See, tangent now is y divided by x, but y is the sine function, right? On the unit circle, the y-coordinate is sine, and the x-coordinate is cosine. So yeah, tangent is opposite over adjacent, but it's also sine divided by cosine. Whoops, sorry about that. I'm not going to try to erase it and draw it better. I'd take off half the tangent function. But that's very important. Tangent is sine divided by cosine. All right, and it's never really been phrased that way before. It's always been opposite divided by adjacent. Now we can think of it as sine divided by cosine. All right, pause the video now and write down anything you need to. Okay. Backside of the sheet. So, one of the things you may be asked to do in this course, and certainly further courses, would be to figure out the value of the tangent function for various special angles from the unit circle, right? And this can get a little ugly. So let's take a look at exercise 3. It says, use the unit circle and the definition of tangent in terms of sine and cosine, which is sitting right up here, to find the value for each of the following. Do not leave any complex fractions. So we'll talk about that in a moment. So let's go through it. The tangent of 60 degrees, by definition, is the sine of 60 degrees divided by the cosine of 60 degrees. Now, the sine of 60 degrees is the y-coordinate on the unit circle. So that is root 3 divided by 2. The cosine is the x-coordinate on the unit circle, and that's 1/2. Now, right now we have a complex fraction because we have a fraction within a fraction. So what I'm going to do is I'm going to multiply the top and the bottom by 2. You could also state change, flip, or state change, change, whatever. But that's going to actually cancel out all those 2's, and that's going to leave me the tangent of 60 degrees being equal to root 3. That's it. That's the whole deal. So what I'd like you to do is pause the video now and see if you can do the other 3. All right. Well, letter B is one of the nicest tangent values you get. Tangent of 45 is going to be the sine of 45 degrees divided by the cosine of 45 degrees. But the sine of 45 degrees is root 2 divided by 2. And the cosine is root 2 divided by 2. And anytime you divide a number by itself other than 1, you get 1. I'm sorry, other than 0. You can't divide 0 by 0. You can certainly divide 1 by 1. Whoops. Anyway, let's take a look at the tangent of 150. That's going to be the sine of 150 divided by the cosine of 150. All right. The sine of 150 is 1/2. The cosine of 150 is negative root 3 over 2. So we have that complex fraction business going on. So I'll multiply top and bottom by 2. And I'll be left with negative 1 divided by square root of 3. Now I'm okay with that, but you may have a teacher that doesn't like a square root in the denominator. To get rid of that, I showed you this trick once before, you do what's called rationalizing. You multiply top and bottom by that radical in the denominator. Now, of course, negative 1 times root 3 is negative root 3. Root 3 times root 3 is positive 3. So you might have some teachers that require you to leave it in that form. Okay? Who knows? And I've just about run out of room for letter D. Let's see if we can sneak it in. The tangent of 180 is the sine of 180 divided by the cosine of 180. All right, the sine of 180 is 0. The cosine is negative 1, and 0 divided by negative 1 is 0. All right, so there you have it, evaluating the tangent functions for some of those special values based on the unit circle. You could verify all of these on your calculator if you put it in degree mode and you typed any of those in. Of course, the radicals would be a little bit ugly, but you could then evaluate decimals to see if they're equivalent. All right, pause the video now and write down anything you need to. All right, let's clear out the text. Okay. This problem says consider the angle theta equals 90 degrees or pi over 2 radians. State the values of sine and cosine at this angle. Now, even if we weren't given the diagram of the unit circle, these should be a piece of cake because 90 degrees is up here. And of course, that's at the point 0, 1. So that means that the sine of 90 degrees, which is the y-coordinate, is 1. And the cosine of 90 degrees, which is the x-coordinate, is 0. Now, letter B says, why would the value of tangent 90 degrees be undefined? Why would this be undefined? Get my writing pad a little bit closer. Well, let's just investigate it. Seems like we should get an answer. Tan of 90 would be the sine of 90 degrees divided by the cosine of 90 degrees. The sine of 90 is 1, and the cosine of 90 is 0. Ah, now I see. It's going to be undefined because you cannot divide by 0. You cannot divide by 0. It's that simple. All right. Now that's interesting. Sine and cosine are defined everywhere. Any angle you want, toss them into sine or cosine, you're going to get an answer out. But tangent has all these different angles at which it's undefined because there's all these different places where the cosine function may give you an output of 0. And that will be a problem. Anyway, pause the video, write down anything you need to. All right, let's clear out the text. Move on. Exercise 5. At which of the following angles is tangent undefined? So this is kind of a follow-up to the last problem. I'd like you to play around with this. All right? Okay, I like this problem because it brings a lot of things together that we've worked on over the span of this unit, even though it's a multiple choice problem. All right, here's tangent. For tangent to be undefined, the cosine of theta must be equal to 0. But that 0 is the x-coordinate on the unit circle. So the real question is, what are those two angles, right? Well, we know this could be an angle of 90, but it could also be an angle of negative 270, neither of which are choices. 120 is somewhere out here. 120 is definitely not right, and negative 180 is right there. So it's got to be the 270, and it is, right? The 270 is a rotation that does this, and in fact, the cosine of 270 degrees is equal to 0, which will make the tangent undefined. All right, pause the video now. Write down anything you need to there. All right, I'm going to clear out the text. Now, one of the really cool things is that if we know the value of sine or cosine, wow, I seem to have missed an entire problem there. If we know the value of sine or cosine, then we can find the value of anything else. So I'm going to splice in a problem here, okay? There's a problem on your worksheet. We'll come back to exercise 7 in a second. But let's take a look at exercise number 6. That is definitely a first for me. You know I make a lot of mistakes, but this is the first time I've just out and out left a problem out. So let's take a look at it. Exercise number 6, if you're reading off your worksheet, says determine the value of cosine theta. So I want to know the value of cosine theta and tangent of theta. I want to know that value as well. If I know that sine of theta is equal to 5/13 and the terminal ray lies in the second quadrant. Second quadrant. So I got this angle whose terminal ray lies in the second quadrant. All right, and I want to know what the values of cosine and tangent are based on the fact that I know the value of sine. Okay, so let's take a look at what we can do. Well, first I can figure out the value of cosine because I have this thing called the Pythagorean identity that says that when I take the cosine function and square it, and I take the sine function and I square it, I get 1. Okay? Now, I'm looking for the cosine. I don't know what that is, but I do know that the sine is 5/13. All right? So I just keep working down and solving this for cosine, not for theta, but for cosine itself. Okay? And eventually, when I subtract 25 1/69, that's a little bit hard to say, I get 144 1/69. And then when I take the square root of both sides, I find cosine theta is plus or minus 12/13. Very important. Plus minus 12/13. This is where the quadrant now comes in. The quadrant is always given to you so that you can determine whether one of the missing trig ratios is positive or negative. And because we're in the second quadrant, the cosine must be a negative number, right? The x-coordinate is negative in the second quadrant. So the cosine of theta is negative 12/13. So that's one of the two things we were looking for. All right. On the other hand, tangent, we don't have to do nearly as much work on because tangent is simply sine theta divided by cosine theta. Sine theta was 5/13. Cosine theta was negative 12/13. Now this is a complex fraction, so I'll multiply numerator and denominator by 13, and I'll get net tangent theta is negative 5/12. All right. If you're wondering whether or not you can leave the negative in the denominator, you can. But the tendency is with fractions historically to either put the negative in the numerator, so it's negative 5 divided by 12, or to assign the negative to the overall fraction, negative 5/12. All right. Well, sorry about number 6 not showing up on the slide, but pause the video now, then I'm going to clear it out, and then we'll tackle number 7. Okay, I'm going to clear out the text. Let's take a look at number 7. Number 6 is probably going to show up like after the final screen where like the words come up. Anyway, number 7. If cosine theta equals a, where a is greater than 0, and the terminal ray of theta lies in the fourth quadrant, then which of the following gives the value of tangent of a in terms of a? This is kind of tricky. What I'd like you to do is pause the video and see if you can work this one out. All right, let's go through it. Very Common Core-esque in terms of a problem. All right, so a is just some positive number, right? A is a positive number. That's all I really know about it. But I know my angle lies in the fourth quadrant. That's going to help me determine positive, negative stuff. Now, it's asking me for the tangent of theta. And I know the tangent of theta is the sine of theta divided by the cosine of theta. And I know this is equal to a. What I don't know is what that's equal to. All right? But we can use that Pythagorean identity again. Remember that the sine of theta squared plus the cosine of theta squared is equal to 1. So sine theta squared plus cosine theta, whoa, oh, that was my a, right? So that's just a squared equals 1. That means sine theta squared is 1 minus a squared. Take the square root of both sides, and remember something critical about square roots, they don't distribute. So the best I can do is actually put plus minus square root of 1 minus a squared. Now, how do I know which one it is? Well, I want the fourth quadrant, and in the fourth quadrant, sine is negative. So this will be negative root 1 minus a squared. So I can finish this off. Sine theta is negative root 1 minus a squared, and cosine theta is just a. So that gives me my final answer, choice 4. All right, pause the video now, write down anything you need to, then we'll wrap up the lesson. All right, clearing it out. Let's wrap it up. So today we reintroduced you to an old friend, the tangent function. I'm sure you used tangent a lot in Common Core geometry when you were solving right triangles. It's probably the one that gets used the most, and yet we ignored it for the first, 9 lessons of this trig unit. We didn't even look at it, right? In trigonometric modeling, tangent is used a lot less, but we can now define it as simply being the sine of an angle divided by the cosine of the angle. And then this brings forth a lot of different issues. We'll look at some more of them in the next lesson. For now, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.